Good day, ma'am. In this video, we are here to present our learning task about the greedy algorithm and discuss the learning task problem, program code, and its test run. So, what exactly is a greedy algorithm? In simple terms, it is a problem-solving approach where we make the best where we make the best possible choice at each step, without going back to change previous decisions. Instead of checking all possible solutions, it focuses on choosing what seems optimal at the moment. So, in our case, we apply the greedy algorithm when giving change. The system always selects the largest available bill or coin first. Then, it continues with the next largest until the exact amount is completed. This makes the process faster and more efficient, especially in real-life situations like handling multiple customers in a store. That's why the greedy algorithm is very useful because it helps reduce time, simplifies decision making, and work effectively for problems like this.
Good day. In this part, I will explain our analysis for the greedy algorithm applied to a real-life scenario in a grocery store. Imagine that during your free time, you work as a cashier in a grocery store. Your goal is to serve as many customers as possible while avoiding long lines. Since you are paid based on the number of customers you serve, speed and efficiency are very important. However, there is a challenge. The cash register only contains a limited amount of money and is refilled only once per day. Because of this, you must give the exact change using the fewest number of bills and coins. To solve this problem, we used the greedy algorithm. This approach always selects the largest possible denomination first when giving change. It helps minimize the number of coins and bills, making transactions faster and more efficient. Now, let's take a look at the given data. We are provided with a table that shows the price to pay and the payment given by each customer. For example, the first transaction shows a price of 1,724 pesos and 75 centavos and a payment of 20,000 pesos. This means we need to compute the change, which is 275 pesos and 25 cents. Similarly, the second transaction has a price of 1,652 pesos and 55 centavos and a payment of 1,700 pesos, giving a change of 47 pesos and 45 centavos. The same process applies to the remaining transactions in the table. Using these values, we will apply the greedy algorithm to determine how many of each denomination, such as 1,000, 500, 200, and 100, down to coins like 0.25, 0.10, and 0.05, which are needed to produce the exact change using the least number of pieces.
Hi, I am Marc Calvelo, and now I will explain the program code used in our greedy algorithm-based cash register system. This program simulates how a cashier computes change efficiently using the greedy algorithm, and it also calculates how many customers can be served in a day and total earnings based on a fixed service time per customer. The program begins with a function called greedy change, which is responsible for computing the change that should be given to a customer. This function takes one parameter called change, which represents the amount of money that needs to be returned after a transaction. So essentially, every time a customer pays more than the price, this function determines how the change will be broken down into different denominations. Inside the function, we first define a list called denominations. This list contains all available currency values from the largest bill, which is 1,000 pesos, down to the smallest coin, which is 5 centavos. The reason why the list is arranged from the largest to smallest is because greedy algorithm always prioritizes the highest value first. This helps minimize the number of coins in bills used in each transaction, making the process more efficient for a cashier. After defining the denominations, we create two important variables rather. First is the result dictionary, which will store how many pieces of each denominations are used in giving the change. Second is the total coins variable, which keeps track of the total number of coins in bills used in the transaction. So this helps us measure how efficient the greedy approach is in reducing the number of items used. Next, the program enters a loop that goes through each denomination one by one. For each denomination, the program checks how many times that the value can fit into the remaining change using floor division. This step is important because it ensures we always take the largest possible amount first without exceeding the required change. After determining the count, the program stores it inside the result dictionary, so we know exactly how many bills or coins of the denomination were used. Now let's come for updating change value. After assigning a denomination, the program then updates the remaining change by subtracting the value that was already given. To avoid small floating point errors in a decimal computation, the result is rounded to decimal places. At the same time, the program adds the number of coins or bills used to the total counter. So this process repeats until all denominations have been checked. Once the loop is finished, the function returns two values. First, the breakdown of all denominations used, and second, the total number of coins and bills required for the transaction. This allows us to both see the detailed change distribution and measure efficiency. After defining the function, the program creates a list of sample transactions. Each transaction contains two values, the price of the item and the payment made by the customer. This simulates real-life cashier scenarios where different customers pay different amounts. After that, the program then processes each transaction one by one using a loop. For each transaction, it first computes the change by subtracting the price from the payment. Then it calls the greedy change function to determine how the change should be broken down. The result is stored in a structured format so it can be displayed clearly in a table. After processing, the program prints a formatted table showing price, payment, change, number of each denomination used, and lastly, total number of coins in bills. This helps visually verify how the greedy algorithm works in each cases. Next, the program moves to the second part, which calculates daily performance of the cashier. We start by defining the working schedule, which is 8 hours per day. Since each hour has 60 minutes, we convert this into a total of 480 minutes. After that, we then assume that each customer takes approximately 3 minutes to be served. This includes the time needed for payment processing and computing the change using the greedy algorithm. This assumption helps us estimate how many customers can realistically be served in one working day. Now, to compute the total number of customers, we divide the total working time by the time per customer. So here we use floor division because we can only count complete customer transactions. Next, for daily earnings, we define that each customer gives a fixed income of 50 pesos. So to compute total earnings, we multiply the number of customers served by the earning per customer. And finally, the program prints all computed values, including total working time, service time per customer, number of customers served, and total earnings for the day. And this provides a complete summary of the cashier performance using the greedy algorithm systems. So in conclusion, this program demonstrates how the greedy algorithm is applied in a real-world cash register system to efficiently compute change, reduce processing time, and estimate customer capacity and daily earnings. After this discussion, the next member will proceed to demonstrate the execution of our program by running all test cases and explaining the output results in detail.
Hey everyone, so for my part, I'll be walking you through the actual output for our greedy algorithm program, explaining what each part of the result means and why the numbers came out that way. Now let me go ahead and run it. Now, as you can see from the output, so we have two main sections: the change denomination table up here, and the daily payout computation down below. Let me go through them one by one. Now, for this table, so this table has 5 transactions for each, as you can see here. For each one, we see the prices, the customer's payment, the change that's owed, and then the breakdown. Exactly how many of each bill or coin the cashier should return. Now, the whole point of the greedy algorithm here is always give the largest denomination that fits first, then work your way down the that way you use the fewest pieces possible. Now, an example for this first price. As you can see here, the price of an item, let's say the price of an item is 1,724.75 and the payment of the customer is 2,000 pesos. So the change should be 275.25. Now, so what we'll do here, what will the greedy algorithm will do is the algorithm checks from the top. As you can see here from the top, it checks 1000 to 0.5. Now, it will check that to match the change like this. The algorithm checks from the top. 1000 too big, no, it will skip it. 500, it's still too big. Next, 200, it's right. As you can see the change, there's 200. Now you have 1. 100 next, it's still too big. Then 50. Now you have 75. You have 25 change now. Next is 20. 20, it's checked because as you remember, the change remaining is 25.25 now. It's going down under. 10, it's still too big, it will skip it. Then 5. It will check it because the balance that was remaining is 5.25 before that. Next is 1. It's still too big. And 0.25. As you can see, it will check it because it matches the change that was left, which was 25 cents left. Now, so the pattern is consistent across all 5 algorithms, across all 5 here in the table. So the pattern is consistent across all 5. The algorithm grabs the biggest denomination that fits, subtract it from the remaining change and repeats all the way down until nothing is left. That's why the totals are always the minimum possible number of bills and coins. Now, next is the second part. By computing how many customers we can serve in a day and how much we earn, as you can see here in the step 1, step 1 is just the time conversion. We work 8 hours multiplied by 60, that gives us 480 minutes of total. Now, for step 2. Step 2 sets the assumed uh, service time. Let's say 3 minutes per customer. This covers the full transaction, which is scanning items, accepting payments, and giving change. Now, the greedy algorithm specifically helps with the last part. Instead of manually figuring out which coins and bills to return, the algorithm computes it instantly. That's what keeps the change giving step fast and error-free. Now, you may ask, what is the 3 minutes? 3 minutes is an assumed average. Let's say some customer will be faster and some slower, but it's a reasonable estimate for a busy grocery counter. Now for step 3. 480 minutes divided by 3 minutes per customer equals to 160 customer. We use floor division here, so only full completed transactions are counted, no partial customer. Next is, let's say we have step 4. Now step 4, 160 customer times 50 per customer equals 8,000 in daily earnings. As you can see here, that is what we get in the final result. To wrap it all up, the greedy algorithm works by always picking the largest denomination that still fits into the remaining change and repeating until the total reaches 0. This guarantees the minimum number of bills and coins every time. The computation is instant, and as we saw in the output, it handles all 5 transactions correctly. That's everything for my part, and thanks.
Hello everyone. In conclusion, the greedy algorithm was effectively used in solving the change-making problem by always selecting the largest possible denomination first. This approach minimizes the number of coins and bills needed for each transaction and ensures an efficient way of giving exact change. Additionally, the same greedy concept was applied to time-based scenario, where working hours were converted into minutes to determine the maximum number of customers that can be served in a day. From this, the total daily earnings were also computed based on the number of customers served. Overall, the results show that the greedy algorithm is efficient for this type of problem because it makes the best local choice at each step, leading to practical and optimal outcomes in real life application like cashier system and management. Thank you. Bye.